Alright. Good afternoon, guys. So yesterday we were discussing
Afternoon, sir.
what was the topic yesterday? Translations and then HSRRP we have seen. Okay. So today we'll see DHCP, DNS, and if possible, we'll complete TFTP also. Okay. See, actually, I need one more on only. You want to reduce it? Yes, reduce it. The problem is if you sit here. Okay, okay, Balaji, it's okay. Hmm? That level. Okay. What's the topic? DHCP. Correct. So your today we'll see DHCP, DNS, TFTP if possible. Okay. All those things we'll finish it. If not, we'll stretch it for tomorrow, only TFTP. So tomorrow your class will be IPv6 campus networks. So on Monday we'll see what is AI, what is cloud, what is quality of service, what is VPN, those things. On Tuesday we'll see SNMP, syslog, AAA, and still there is one more concept something, and then we'll see wireless. By Tuesday your class will be over. Okay. What is the Tuesday date? I think by 15th your CCNA is over. Okay. I should have completed by tomorrow actually. I took 2 days off in between, right? I was not feeling well, so 2 days class we missed. So that's why you're stretching it for the next week. Otherwise, by this week it will be over. But it's okay. What is DHCP? Dynamic? Dynamic host control protocol, and in which server is using port number 67 and client is using 68. Okay. 68. And then it is a write down, it is a utility which provides automatic IP to using it is a utility which provides automatic IP. So what we are doing, we are doing static IP, right? Statically, we are going to the PC and saying, okay, this is the IP, this is the subnet mask, this is the gateway, default gateway we're saying. But whereas your DHCP, it automatically does that. Okay. So for this purpose, DHCP process is called DORA. What is DORA, Dinesh? Hmm? DORA, you don't know? You haven't seen DORA? Doraemon Dora. Not Doraemon Dora. Dora means discover, offer, request, and acknowledgement. So to configure DHCP, we need to have a system which is going to act as a server. Okay. The next point, on this server, we are creating a pool of address so that all the client system get automatic IP from server, and it is used to dynamically assign IP address to the client system. Write down these things. Written. See, why we are using this DHCP? See, if there are like 4 or 5 systems in the organization, that is fine. You can go and do it statically. Correct. What if it's 200 PCs? What if it's 500 PCs? Is it possible? Yes, it is possible, but it will become very hectic for a network admin to go and assign IP on each and every system. Okay. So, and that also, and another one point is like, see, for example, if the range is like starting from 1, okay. So I'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, like that I'm assigning. See, in between, I may forget 16 and go to 70. Correct. And then at last, one will be remaining. And then I have to find which one is it. I have to perform all the commands and then check. And then I will assign the 16th IP. Likewise, it may mismatch if you are doing it statically. So instead, we are using this dynamic host control protocol where it is going to give automatically IP. How it is going to give automatic IP? Through a process called DORA. Through this DORA process, your PC will get IP from the respective DHCP server, and also it is not just going to give the IP. So write down another point. So DHCP provides one IP address, two is subnet mask, and then default gateway, and also your DNS server. All these things your DHCP provides. Written? Okay. So what is DHCP? Dinesh, first point, read it loud.
Dynamic Host Configuration Protocol, DHCP, is a network management protocol used in networks to dynamically assign IP addresses and other network configuration information like default gateway, mask, DNS server addresses, etc. DHCP is a layer 7 protocol and works on UDP. DHCP uses port number 67 for the server and 68 for the client.
So it is using 6768 for the client. It's dynamic host configuration protocol, and it is used for dynamically assigning the IP address. That is the goal. Okay. You read the second point? Yes. Yes.
DHCP server automatically assigns IP address to various devices in network.
Mhm.
This in turn reduces work for network administrator to manually assign IP address to various devices.
Correct. That is the point we discussed. It is hard for the network admin to go and manually do it for each and everyone. So that is the reason we are using this DHCP configuration. Uday, next process.
Automatic IP address assessment process
Mhm.
undergoes four messages exchange.
Mhm.
These messages are abbreviated as a discover, offer, request, and acknowledgement. DORA.
So this process is called DORA process. So that means assigning the IP addresses through this process. Okay. Configuration. Change it here. Configuration protocol. So control, sorry. Excuse me. And then, see, this is the important thing. So the following table gives the details of DORA procedures. See here. So how your DHCP provides these things? Okay, that means the process, how it is happening. Okay, so we are having a topology like this, and this is my DHCP server. Okay, and I want IP for this PC1. Okay, what is the first message? That is called your discover message. Discover message. What happens is in this message is this PC will try to find who is my DHCP server. I don't have IP. Tell me who is my DHCP server. So he will do the broadcast. What he's going to do? He will do broadcast. That means he'll send it to a switch that asking, is there anyone called DHCP server in my network? That is the meaning of the discover message. So this packet will be went to PC2, PC3, PC4, and also router 1. So this PC will drop the packet, this will drop because they are not the DHCP servers. And this will see, okay, they're requesting for DHCP. So I should give them the required details. So he will do, what he will do, he will again broadcast. He will again broadcast the offer packet. So in this offer packet, he will give the IP address, subnet mask, default gateway, such things, and he will ask, is it okay for you? This is the details I'm going to give. Okay. And then this PC, right, he will perform something called GR. You remember I said this about in your R class? What is GR? What is GR?
Use valid IPs.
Correct. To check the duplicate IP. That means, say for example, I'm in this network 10.1.1.0/24. Okay. And here the IP is .10. Okay. So here I'm already having .1. Okay. Here this PC is having .2. Okay. And this PC doesn't have IP, and this is the PC requesting. Imagine like this. So if first he has requested for discover packet, again offer packet has come. During this request, he will perform this GR asking, is there anyone called 1.3? Okay. First, if he is asking, is there anyone 1.2? Is there any 1.2? Yeah, 1.2 is already there. So he will reply, right? That means there is already someone in that name. So he will re-request again. Okay. Then he will give the another IP, the router. So for example, he's giving 1.3. He will ask, is there anyone 1.3? Will the reply come? No, right? Because there is no 1.3. So in that scenario, he will, okay, this is fine for me. This IP, this subnet mask, this default gateway, everything is fine. I'm requesting for this things. And then again, the router will send the acknowledgement packet. In that acknowledgement packet only, you will receive all your IP addresses and thing. Until this process finishes, you will not get the IP. Okay, backend, this is what runs. Okay, now we'll see the practicals by capturing the packet also. This is just the explanation. Come to your PPT now. See, discover. What does it say? This is the message sent by DHCP client to discover a DHCP server. That means he is sending the broadcast packet asking, is there anyone called DHCP server? An offer packet sent by DHCP server to lease unique IP address and other parameters needed to client. So you will release the IP addresses and parameters in your offer packet. And in the request packet, sent by DHCP client asking server to lease parameters listed in the offer message. That means you will say confirm, okay, whatever you sent is fine for me. And I have checked it from my side. Is there any duplicate IP? There is no duplicate IP. This is fine. Okay. And then he is sending the acknowledgement packet. In acknowledgement packet, you will get the IP address, subnet mask, default router, and gateway, DNS server. Okay. This is the process of DHCP. Okay. First, we will. What are the advantages? So centralized management of IP address, easy to manage, ease of adding new clients. If new clients come to the thing, directly you can say DHCP and they'll get the IP address. So reuse of IP address, reducing total. See, for example, if there are 50 IPs, so 1 to 20 used, and the person between 20 to 25 are not using. I mean, say 15 to 20, they have disconnected. They're not using the IP. Again, the IP will not be started from 21. There are IP less, right? Leftover IP 15. Again, it will start from there only. It will not use the new IPs. It will keep reusing the used IPs. Once if it's exhausted, then it will go to the 21, 22. So that it is easy to manage also. Okay. And simple reconfiguration of the IP address based on the DHCP server without needing to reconfigure each client. One configuration on router, that is done. For every, I mean, for the complete network, it is fine. You'll be able to request and get the IP address. Okay. Now we'll see the practicals. Okay. And then again, we'll come and see what is the packet amount. Okay. Okay. First, I'll do the basic IP addresses. Done. Now I'm saying interface. First, I'll create the pool IP DHCP pool. Pool name I'm saying CCNA. Okay. First, I'm creating the pool. First, I've given the IP addresses, and now I'm creating the pool. Inside this pool, I'm going to say the networks. So after creating the pool, say IP, say the network. So what is the network? 10.1.1.0, 255.255.255.0. Correct. Done. After this, I'm going to give the default router. What is the default router? 10.1.1.1. Default router is given, network is given. I've created the pool. Okay. Now inside this pool, I've created this network. Correct. All right. After this, I'm going to say the DNS server. DNS server, simply I'm saying 8.8.8.8. Random DHCP servers I'm giving. And then one more thing you can do is IP DHCP exit and say IP DHCP pool exclude. What is the pool? CCNA. Correct. IP DHCP exclude address. Exclude address. 10.1.1.25. So first IP is given for the default gateway. From 2 to 25, I want to reserve it. If someone coming from, say, for example, I'm in Bangalore branch, okay, and there are clients coming from Hyderabad. So for them, they'll just use for 1 or 2 days, and then they will leave. So for them, I'm reserving some IPs, 24 IPs. So that IP will not be assigned to our regular clients, regular employees. So that's why I'm reserving this to first 25. So I'm giving the range from 10.1.1.25 to, from 25 to 50, what I'm doing is reserving. So what I'll do, from 2 to 10.1.1.25. Okay. So this many IPs will not be given to my actual employees. So these are reserved for later purpose. Given. Now go to this PC. Packet is generated. Click on this packet. And what packet is it? Discover packet and sends out. Okay. And here you can see source port is 68. That means server is sending to destination port what? 67 client. Okay. And what is the MAC? It is a broadcast. See? So they will drop it because they are not the DHCP server. He said tick. That means he accepted the packet. Correct? Okay. Now he will send back the. This is what packet? Offer packet. So in the DHCP packet, he is saying client address, I am going to give you 10.1.1.2. Okay. Server address is 10.1.1.1. Relay agent address. Relay agent address is different. As of now, leave it. So server host name, all those things he will give in this place. Okay. So send it to him. Those two are rejected it because they are not the requested the packet. They are not the actual person. This is the person who requested it. So here you can see now. What packet is it? Receives a offer packet. Construction sends out a request packet. That means I've sent you the offer packet for the discover. You asked. So now you construct and send me the request packet. And then I will give you the IP. Now he will send it back. What packet is this? Request packet. See, this is the request packet which is sent from your client to server. So source port is 68, destination is 67. This is the packet he is going to send it back again. So source port has become 67, destination is 68. So source IP is 10.1.1, but destination is broadcast because he don't know who it is because he doesn't have IP yet. Correct? All right. Now he will send it. See, until now, there is no IP. Can you see any IP? Now click, he got the IP. Okay. So likewise, you can do the DHCP thing. Okay.
So you have
Excluded. Yeah. Let me check. One command I've given wrong, I suppose. IP DHCP exclude address. Okay. What happened?
Subnet mask not given.
Subnet mask is not required. Give it from the default gateway. I've given from 2, so that's why it is not taking it. So 2 from 2 to then. So 2 has taken it. Okay, from 1 you have to give. So now we have got the IPS 26. Okay. Now I'll request for this one. What will be the IP? 27. I got subnet mask, I got default gateway and also DNS server. So it is taking 1.5 seconds, but between this 1.5 seconds, all these processes are happening. Discover, offer, request, and acknowledgement. Until the acknowledgement comes back, we are not having the IP address. Understood? See, I'll request from here also. Yeah. So likewise, we can do the practicals. Okay. Now, what is this discover message? Okay. One of you read loudly. Who's going to read? Dinesh, first message.
This is the first message generated in the communication process
Mhm.
between server and client.
Mhm.
This message is generated by client to host in order to discover if there is any DHCP servers are present in a network or not.
Mhm.
This message is broadcasted to all devices present in a network to find the DHCP server.
Correct. So this is first of all, what is it? It is a message from first message generated between the client and server, and it is generated by who? Client. For what? To find the DHCP server within the network. Okay, and it is a broadcast message. These are the key points you have to remember in your discover packet. First packet generated by client. It is a broadcast, and for need for it is to identify the DHCP server. Okay, all right. Devidas from online. Please read the offer message. Are you there, Devidas?
The server will respond to host in this message, sacrificing the unleased IP address and other TCP configuration information. This message is broadcasted by server. If there are more than one DHCP servers present in the network, then client host will accept the first DHCP offer message it receives. Also, a server ID is specified in the packet in order to identify the server.
Correct. So this is what he is giving the IP addresses. What IP, what subnet mask I'm unleashing for you. Okay, and tell me if this is okay for you. That is the offer packet. So this message is broadcasted by server again. He doesn't know who the person is. So that's why it is broadcasted. And if there are more than one DHCP server, see, this is one important thing. In this topology, here I'm having DHCP server. Here I'm having another router connected to a switch. And here also DHCP is connected. In that case, what your switch will do, your PC will do, whichever server is going to send the response immediately, it will take that IP. Okay, whoever giving me first, it is going to accept that. Okay, that is what they have said here. See, the message is broadcast by server. If there are more than one DHCP servers present in the network, then client host will accept the DHCP offer message it receives from the nearby DHCP server. And they have the server ID is specified in the packet in order to identify the server. So server ID will be there. Okay. All right. Next message is request message. What is this request message? When a client receives the offer message, it responds by broadcasting a DHCP request message. Okay, after getting the request, you will say, okay, this is fine for me. I'll get the IP. But the client will produce a gratuitous ARP in order to find if there are any other host present in the network with the same IP address. You'll come to know, is there anyone from this IP? Is there anyone 10.1.1.6? He will ask. Will the reply come? No, the reply will not come because there is no one. Okay, if the reply doesn't come, he will accept the IP. If the reply comes, then there is someone. So I don't want this. So that is the reason of GR. Okay, and then if there is no TCP conversation, broadcaster to server showing the acceptance. If there is nothing, no reply comes, then he will accept, okay, this whatever you release for me, fine for me. Now I'll request for you. You give me the IP. And then in your acknowledgement packet, in response to the request message received, the server will make an entry with specific client ID and bind the IP address offered by the lease time. Now the client will have the IP address provided by the server. So in your acknowledgement packet only, your end devices are getting the requested parameters that we requested for. Okay, so this is your DORA process. Not Dora the Explorer, Doraemon, Dinesh. Okay. Any doubt on this? Okay, write down these comments. Mhm.
When client get the IP address in offer packet or acknowledgement packet,
In offer acknowledgement packet.
then what is the reason for
Offer packet.
He sent to request packet to the DHCP.
Offer packet he is leasing. Is this parameters are okay for you? He's not giving it. He's just saying, is it okay for you? In request packet again, he is checking the very details, whatever you sent me. Okay, this is fine, this is fine. Fine for me. And then he is requesting, after receiving the request only in acknowledgement packet, he will release the IP.
But only DNS server is important.
Why?
DNS server.
Server, because I need my server, right? It's not that DNS server is this one only. Any server will be there where I'm going to use. What is this DNS server is your next concept. Okay, after this DHCP, I'm going to explain that DNS. So there only you will have all the IPs. You're using this Google, Facebook, everything you're using, right? YouTube. So that IP, how you're getting that IP? I'm saying simply ping google.com. I'm getting the replay. How I'm getting the replay? So all those details are in your DNS server only. How many of you did practicals yesterday? Be honest and tell me. Translations practicals, offline. Except Mohammed. Why? Why nobody did? What do they? Why you didn't do? What about you? Why you did not do? Vishal? 2 practicals you did. What are the practicals you did? Konsa? Ah. Oh, HSRRP. What about you? Good answer. Studying PD. You? Why? Doubt you have. You went out with girlfriends. See? Wednesday is going out with. And imagine on weekends.
Not every
Yeah. What about you, Imanshu? Why you did not complete? Oh, yeah. Telling. Roni? Working, yeah. That is fine. Oh, sir, superstar. You're not feeling well. Okay. Huh? Weekend. Oh. Monday to Friday, I can't. I'm busy. I'm not I can't do it. Only weekend I work. Totally ulta. What, sir? You are laughing. Why you didn't do?
I will do market, sir. Full day.
You went to market.
Yes, sir.
What you're selling?
Shopping, sir.
Shopping. Nibin, you don't know. You don't know why you did not do practical. You have laptop. You have Cisco packet tracer. Then why you did not do? Busy. What about you two guys? You did either channel. In either channel, what did you do? Huh? PAGP. What is the command for that? Okay, you did something. Okay, I accept. What about you? You are preparing. Guys, today we have interview. You're supposed to give interview by now. In NH, we are having interview today, 1 to 4. Okay. You guys are completed CCNA. Your basics are over, routing is over, switching is over. Correct? Only DHCP and some management protocols are not there. So by now you should have given the interview. But you're not doing the practicals itself. If you don't do practicals, I'm telling you again, your CCNP routing will become very difficult. Ask Mohammed because he is doing this routing. How much practicals are there comparatively? All complex, right? Everything are complex topologies. So you will not understand there. It will become very hectic. Every day I'm keep telling, but nobody is doing it. Very bad. What about online? These guys are Hemant, Devidas.
Sir,
Hmm.
I have come only up to that. What is that?
You don't know what you have come to.
No.
Uh,
That
which
just before either channel topic. No.
before Eater channel topic? No, you're asking me. What did I
That
talk to you before Eater channel? Huh?
no. That DR, BDR, BPDU spanning tree protocol.
Oh, you're still in spanning tree only.
Yes.
Okay. What about Hemant? Hemant, Manoj,
Sir, I should do, sir.
you should do. Anybody working in online currently? Or reply. I should do it. I should do it. Why you didn't do it? I know you should do it. That's what I'm saying. You should do it, but you didn't do it. Okay.
Sir, this weekend I will complete.
All right. See, no others are asking like this because CCNA is important. That's why I keep asking like do it, do it, do it. You will not know now. After 2 months, you will come to me. I'm telling you. Write it down. In interview, you will come and sit next to me, right? Okay. Now we are going to see another scenario. That is now same DHCP, but my server, DHCP server is not this router. It is this server outside the network. Okay. This is outside the network. So initially what this PC will do, he will request, I mean, what packet is generating first? Discover packet and use it to discover the DHCP server. And he is doing the broadcast. So the packet will be generated. He will be broadcasting to router and two PCs. This is the DHCP server? No, this is not the DHCP server. I'm going to keep the DHCP server outside the network. So these two PCs are not the DHCP server. So simply all will drop. Correct? So how I am going to identify this server which is outside? That's where your DHCP relay agent comes into picture. Okay. One small definition you can write DHCP relay agent. Used when the DHCP server is present in the different network. Used when the DHCP server is present in the different network. Written? Okay. Now, go to CL. Excuse me. Interface gig 0/0 0 IP address 10.1.1.1 255.255.0 no shutdown. Done. Okay. Now go to the server. Here you can see services. Before that, go to configuration desktop and give IP for it. So I'll take IP as 1.1.1.1. One dot one dot one dot one 255.255.0 1.1.1.10 I'll take as the default gateway. Okay. In the services, this interface is also there right here. Interface gig 0/1 IP address is 1.1.1.10 I'll take. No shutdown. Done. Now go to this one services, go to DHCP. In DHCP, default gateway is what? 10.1.1.1, correct? DNS server, I'll say 3.3.3.3 random. Start IP is what? 10.1.1. I will say 50. Okay. Subnet mask is default subnet mask. Save the configuration and on the pool. Okay. Here it is there already. Now, see, without this, wait. Click on DHCP simulation. See, the packet has got dropped. 2 packets are dropped. Why? All the 3 packets dropped. Because there is no DHCP server within the network. Correct. There is no, because my DHCP server is here, 1.0 network. But I'm in 10.0 network. That's why you see XXX. So what I'm going to do is go to this router and I'm saying interface gig 0/0. Gig 0/0. IP helper address. IP helper address is what? 1.1.1.1 is the IP of the server, correct? What is the IP? 1.1.1.1. Give enter. Okay. See, before that, the DHCP did not work. Can you see 169.apipa is failed? So apipa address is used. So here DHCP has failed. So static, now give DHCP. 10.1.1.50 I got, correct? And gateway 10.1.1. What is the DNS server? 3.3.3.3. Whatever I've given there, I got it. It is because of your DHCP relay agent. Okay. Another one important question they will ask in interview. This is a PC. Okay, my DHCP server is in different network. How the packet flow will be? So initially it will broadcast to everyone. Okay, he is going to drop it. He is going to drop it, and this router is going to do the unicast till here it is broadcast. Okay. And while it is sending to this site, it is unicast. Why? Because your router is not going to do the broadcast. It exactly know who I need to send. Okay. If I know, if I'm within the classroom, okay, and I'm saying, okay, send it to this person, it will send it to person. Even if it's in other classroom, you will exactly go and give it to that person only. Likewise, if it's in other network, the router will know this person I have to give. Why? Because of the DHCP relay agent. I'm giving interface IP helper address, right? So that concept is called relay agent. Okay. Any doubt on this? No. Just this command, one command, you can write it down. Interface gig 0/0 and IP helper address 1.1.1.1. Written? Okay. Next concept is DHCP snooping. Write down. It is used to avoid rock DHCP or unauthorized DHCP server in the network. Okay. So for example, see, I'm working in the organization. Okay. I'm the internal employee. All right. So what I bring another router and I connect it to the switch like this and make this one as DHCP server. Don't fall. This is my DHCP server. What I'll do, I'll simply take a PC first. I'll request for the IP. So I'll get the IP address. If I get the IP address, I'll understand what is the network it is there. I'll get IP address and subnet mask, right? In that IP address and subnet mask, I'll come to know which is the network it is using. And then default gateway will be given. I'll come to know about the default gateway also, DNS also. Correct? And then in my router, okay, that is router or DHCP server, it doesn't matter. Anything. Okay, what I'll do, I'm going to give the same IP address. I'm going to give the same subnet mask. But instead of default gateway, I'm going to give this one as the default gateway. My unauthorized router as the default gateway. DNS server is same. But what happens when a packet goes outside of the network? It is going to use this DHCP server. The way will not be like this. This is the actual way, the front door. But I'll change the door as like this. That means what I'm doing, I'm putting a curtain there so that you will not know. You will use this door. That is the wrong door. So your packet will be forwarding through unauthorized router. So I'll be able to capture the packet and see what is it. Correct? I don't want to do that. How I'm going to save that? That is your DHCP snooping. Okay. That means I'm going to what do you say? Avoid the unauthorized PC DHCP server to give parameters to my own PC. Okay. So first I'll take one router. See, if I have a DHCP server here also I'm having DHCP server. Which one it will take? This one. Why? Why it will take this one? I can't hear you. Exactly. This router is closest one because inside the packet goes to this router. He has to forward it here. Again, this server will forward to router and then it will forward here. Meanwhile, this router will immediately give the offer packet. Correct. Once the discover packet hits the router, immediately is going to give the offer packet. Once the offer packet reaches this PC, he will take this one. He is not going to take the other one. Okay. So host name I'll say unauthorized server. Okay. Interface gig0/0 IP at 10.1.1.100. No shutdown. Done. Now IP DHCP pool. I'll say CCI. Okay. Network 10.1.1.0. 10.1.1.0, right? Correct only. 255.255.255.0. Okay. Then what? Default router 10.1.1. Why will I say 1? I'm going to give this router as the default gateway. So I will say 100. I don't want you to use the correct door. I want to use the unauthorized one. Then DNS I will give same 3.3.3.3. Okay. All good now. I'm not excluding any addresses. Just leaving, or I'll say IP DHCP exclude address 10.1.1.1 to 10.1.1.10. Done. Now, does this IP have this PC have any DHCP? No. I'll just request for it. See, what is the default gateway? 10.1.1.100. IP is within the network only. You'll be able to use it, but packet will flow through this way. It will not go like this. It will go like this. I'll ask request here also. Go to static DHCP 1.1.100. I don't want this to happen. What I'm going to do? Go to this switch. Okay. So this thing we are doing it in the switch. Enable. Say IP DHCP snooping. First we are enabling the snooping and then say IP DHCP snooping. What is the VLAN number? By default, all are in VLAN number 1. So I'm saying VLAN 1. After enabling DHCP snooping, after enabling the VLAN 1, which interface you have to trust? Interface F0/4. This is my interface which I trust. So I say interface F0/4 IP DHCP snooping trust. Enter. Okay. I'm just saying I trust only this one, not this one. So now go to this PC. Now see, it is 10.1.1.1. It is not going to get it from the, though there is another server within the network, but I will say don't trust it. Trust only the packet comes from F0/4 interface, not this interface. Okay, see here I'll get it. Ten dot 1.1.1. Okay, this is your snooping. Any doubt on your snooping? Yes or no? No. Write down the commands for your snooping. Devidas, any doubt?
No, sir.
No. Here interface F0/1 4. Written, guys. Now done with DHCP. Now we'll go to DNS. What is DNS? Any idea?
Convert domain.
Okay. And then see, DNS is like your contacts, mobile contacts. Okay, simple. See, whose number you will remember? Like, how many numbers can you remember? One, two. Huh? Only one. Only your number you are able to remember. See, you should remember at least 3, 4, 5 numbers. Correct, Ronnie? Okay. See, 1, 2, 3, 4 numbers you can remember. Likewise, the IP addresses you can remember 1 or 2 maximum. It is not possible for us to remember all the contacts. So what we are doing, we go to the mobile, go to contacts, we search by name. Correct? If you are going to save it as baby, then you will save it. You will search as baby. Correct? Correct, Uday? No?
No, sir.
No. So whatever the name, you're going to give it and you'll get the number. Likewise, same thing happens in a DNS. I'm saying google.com and I'll get the IP address, not phone number. Google doesn't have phone number, only IP address is there. So you'll get the IP address. Vice versa. If I'm going to give the IP address, it is going to give me the name. Sometimes in the notepad, if you type the number, up the name will come, right? Same like that. So that is called your DNS. In simple to remember how it works, give the name, you get the IP address. If you give the IP address, you'll get the domain name. Both the ways, just not name to domain name to IP address, but also from IP address to domain name. Okay. See, what is DNS? Domain name system. It resolves domain names to IP addresses and vice versa. Okay. That means DNS is a application layer protocol. So DNS works on port number 53 and uses UDP and TCP. Okay. So where it is using UDP, for general queries, it is using UDP. But if it's want to share all the information to another DNS server, okay, complete information he has to share. At that time, it is using TCP. Okay. But general queries, it is using UDP and port number is 53. Okay. Write down these things quickly. Written, guys? Okay. Now come here. Your DNS. Okay. It has DNS resolver first. Okay. So if this resolver doesn't have this IP address, then there are three things. First one is root name server. Sorry, excuse me. So first we are having this root name server. Okay. What are they? That's my roommate. He's not well. Okay. I know you. Okay. First we are having root name server, domain name server, and authoritative server. Just joking. Okay. So first I'm saying ping youtube.com. Ping youtube.com. Okay. In this case, what will happen? This root name server. So first it will check the resolver. The resolver will not have the details. And then it will send it to root name server. In the root name server, it is going to resolve the .com part. Whether it is .com, .in, .us, .uk, .org, whatever it is. So it is going to resolve this .com part, your root name server. After that, you will send it to resolver. My part is done. If you want to resolve the name, you send it to top level domain name server. So he will again send it to TLD server, top level domain name server. Okay. And he will resolve this name part. Google or YouTube or Instagram or Facebook, whatever it is, is going to resolve that name part. Which one? Your TLD server. And after resolving that, again, he will send it back to resolver. So now resolver will send it to authoritative server. Authoritative server has the IP address. See, for example, if I say Google, it will tell you whether it is mail.google.com. What is the IP? Okay, if I try for drive.google.com, it will give you that IP. Okay, if it is gmaps.google.com, then that IP. So all the IPs, it will be in your which server? Authoritative server. And then he will send it back to the DNS resolver, and then you will be able to ping the network. Okay, but initially when you say ping youtube.com, you're getting reply in seconds. But before that, all these servers, it will touch and come, which you will not know. First proxy auth will be there. First it will try to resolve the MAC address, and then ICMP, and then again this DNS server address, where the address is. So if address is not in the resolver, it will touch the root name, domain name, and then authoritative server. It will resolve the IP. Then only you'll be able to use this ICMP, that is ping. So back and all these process happens. Okay. Now check the present PPT. See, types of DNS server. First DNS resolver is there. Root name server, TLD server. That means top level domain name server and authoritative server. See this? How a computer loads a website using DNS. That means first I'm trying to ping this Facebook, www.facebook.com. Okay. In this case, what is happening? First, he will send it to root name server. So he is going to say resolve the .com part and send it back to resolver. Again, resolver is sending back to TLD server, and here the name is resolved. See, .com TLD name server. That is, he is going to resolve this Facebook. Okay. After that, again, he is going to send it to authoritative name server. Okay. In the authoritative name server, he is going to store the website's IP address, last server in DNS. He is going to store the IP address. So for the www.facebook.com, he is going to give the IP address. Okay. And then the resolver will have the, see, in your ISP site, they will have all the IPs. If it's not there, then it will go to that part. See here in the cache table, it is already there. Then it will not do all these processes. If it's not in the cache table, then it will do all this process. Then you will come to your laptop and then you will be able to ping it. So this is the backend process. Okay. I think WSA, if I'm not wrong, or ESA. Email. In WSA, you will learn in detail about this DNS amount. Okay. WSA or ESA something, I suppose. But this is the basics of DNS. Yeah, Mohammed, any doubt? Write down the servers' names. Written. Next concept, FTP, TFTP. Dinesh.
TFTP stands for File Transfer Protocol.
Mhm.
This type of protocol is used to transfer or copies the file
Mhm.
from one host to another host.
Mhm.
And in FTP, secure channel is provided to transfer the files between the host or systems.
Mhm.
FTP works on two ports, 20 and 21.
Mhm.
One for data and another is for connection control.
Very good. So FTP is like a file transfer protocol. When you are going to transfer like big files, downloaded files, then we are using this FTP. Okay, and it is more secure. Okay, and works on protocol number 20 and 21. Okay. Now we are going to see this TFTP. It is lighter version of this FTP. Okay, what we are doing this in FTP is a smaller compared to your FTP, but all your configurations part we are taking backup in your TFTP protocol. Okay. See, for example, in your router, we are having like small configurations, like a interface, IP address, router rip, like basic configurations. Whereas if you go to VPN or a firewall configuration, there are like very big configurations. That is like almost a page, 1.5 pages you have, especially VPN. So in that case, what we are doing, we are taking the backup. What if suddenly I'm using this router and the router got corrupted? Okay, all the configurations are gone. Then what I can do? So always we take the backup and keep it in the server. And again, if something happens, we can integrate it back then. How I'm going to do that? Practicals will see. Okay. Again, you will do this practical in ASA firewall, if I'm not wrong. Yeah, in ASA you will do. Just give one IP. Okay. Spingy, connectivity is there. Go to server, services, TFTP. Remove all this. Okay. Now go to this router. Same. Do show. Sorry. Exit. Show. Running. Exit. Show. Running. Running config. Here you can see host name R1, right? And then IP address is there. See, all the configurations are there. How I'm going to integrate with the TFTP server? That means copy running config to TFTP server. Copy running config TFTP. Enter. What is the address or name of the remote host? What is the address? 1.1.1.1, correct? Destination file name I'm saying R1 run. That means R1 running config. See, wait. It is stored. Go to the server, go to TFTP server, you will be seeing R1 run. Correct? So this is how you take the backup of running configuration. What is the startup configuration? Did I save anything? No. I will say show startup config. Startup configuration is not present. Correct. So I'll say, very good. Right. Now say show startup config, you will see the thing. Correct. Now what I'll do, copy startup config to TFTP server. Host is 1.1.1.1. Destination file name, I'll say R1 start. Okay. Now go to the server, say TFTP, R1 start is there. So what if I delete it? I'll delete this startup configuration. Erase startup config. So it is erased. Now I'll say show startup config is not present. How I'm going to integrate it? So copy TFTP startup config. Address of the file name is what? 1.1.1.1. What is the source file name I've given? R1 start. R1 start. Enter. This is the destination file name is R1 start. R1. Wait. First give R1 start. 1.1.1.2. Startup config. Address of the remote host is 1.1.1.1. Source file name give enter. Oh. Source file name R1 start. Destination file name enter. Destination file name just give enter. Okay. Source file name is R1 start. Destination file name just give enter and it is copied. Now see. Initially I removed, right? Erased. There was nothing. Now the configuration will come back to your router. So this is how you take back the configurations back to the server to your router. Okay. Now show flash. So this is my iOS image name. This is my iOS image name. How will I copy this image file name to my server. Okay. So copy flash to TFTP. Okay. Copy flash. So file name, what is the file name which we are going to copy? The image name. So address of the host is 1.1.1.1. Correct. Destination file name, I'll say R1 flash. Okay. R1 flash. Done. Go to the server. R1 flash is, I got the backup of R1 flash. Now go to this router and say delete this iOS image. After that, say reset, sorry, reload. Okay. So what I've did is I've deleted the iOS image file name. Okay. So Dinesh, when you go and work in the organization, okay, just go to the router and don't do delete flash image. If you do that, next day they will fire you. Okay. This is for understanding purpose. Anyone. Okay. So I'm going to, one of my tutor told me this is how I can take a backup. You will have backup. No, you can do that. No, don't do that. Okay, Dinesh. So now what I've done, I've taken the flash of the image name and then I've deleted it. I deleted the flash and I reload the system. Now the system is in which mode? Roman mode. You remember in your first day of practical, use 5 modes I said: user execution, privilege, global, interface configuration mode, and then Roman mode. Where this Roman mode comes in to boot up your flash. It is the Roman mode. Okay. So it will be in your Roman mode. So here I am going to say TFTP DNLD. Okay. If you give this, you can see this parameters, right? IP address, IP subnet mask, default gateway. It should be exactly like this. What is the IP address I want to give to the router? Just say random IP. I'll say 10, 1 dot, 1 dot, 1 dot, 1 dot, 1 only the network. Yes. I'll say 1 dot, 1 dot, 1 dot, say 5. Okay. Enter. It should be exactly like this. Now IP subnet mask, copy, paste, 255.0.0.0 given. Correct. So I'm giving that. After that, default gateway. We don't have any default gateway, but just give a random default gateway. That is 1.1.1.100 I'll say. Okay. And then what is there? TFTP server. This should be the exact server ID. It can't be a random one. What is the server IP? 1.1.1.1. And then TFTP file name is what? R1 hyphen. Correct. Enter. Okay. After that, again say TFTP DNLD. Enter. What? TFTP DNLD. Wait. IP address 1.1.1. What is the IP address given to the router? Remember? 10. Okay, I'll give 10. IP subnet mask. IP subnet mask. It should be exactly like that. Some mistake I've done. 255.0.0.0. Okay. And then TFTP server. What is the TFTP server? 1.1.1.1. And then I have default gateway. Correct. I missed default gateway. Default gateway. Default gateway is what? A random IP I'll give. And then I have TFTP file is R1 hyphen search TFTP DNLB. Now it is correct. Okay. Now invoke this command. Do you wish to continue? Invoke this command for disaster recovery only. Warning all lost. Say yes. Enter. So now it is copying from the server to your router. And now say reset. See, now it is trying to decompose decompressing the image, and you will boot it from there to here. It will copy it and then it is booting. See, directly you can see R1. Correct. Because we already saved the startup configuration in your NVRAM. So NVRAM is not corrupted. Only your flash memory is gone. So once the flash memory has come, it is trying to boot the image and start the router. After that, in your NVRAM, all right. Online guys, I'm sorry, there was some internet issue. So
Sir, your screen is now it came.
now it is visible. Okay.
Yes.
So now you can see
Yes.
directly we are in the NVRAM. So in your NVRAM, already the startup configuration is stored. So that is the reason directly we are able to see this R1. Okay, don't get confused with your NVRAM and flash memory. Flash memory is got corrupted and we deleted it. That we took backup from the server and we have reinstalled in the system. Correct. And then it tries to load the image, and in your NVRAM, it loads the startup configuration and directly you're getting this R1. Now if we say enable, and you can use this computer. So this is how you take the backup of your TFTP server. Okay. Any doubt on this? Okay. So try to see the recording once again of this TFTP and try to do the practicals. It's quite interesting, your TFTP. Okay, because you take the backup, you again take it backup of it, reinstall it, take the flash memory, all these things is good to do it. Okay. So that's it with your today's class. So we have completed DHCP, DHCP Relay Agent, DHCP Snooping, and TFTP. So tomorrow's class is IPv6. So we will learn what is IPv6 addresses. There is something called shortening rule that we are going to learn. And then we'll do an IPv6 routing. Okay. And then we'll see campus networks. Okay. Since some topics are there, we'll discuss those things. Okay. Let's wind up here today. And you guys, what? Hmm? What task I given yesterday for offline guys? Some interview topics, right? So online guys, you have any doubt? Uh, Online guys, any doubt? Devidas? All right.
No, sir.
All right. Good. Thank you. I'll see you guys tomorrow. Okay.
Okay. Thank you.